I need the help. I'll take all the help on remembering to record I can get. All right. So here it says, what happens to the graph of y equals f of x if the following changes are made to the equation? You replace the x with x plus 2. So replace means I go in, I take the x, I toss it behind my head, and I replace it with x plus 2. So I'm going to get y equals f of x plus 2. In words, what would that be? Horizontal translation 2 to the left. Mapping in words, what do we know about them? They're the same thing. So if I'm saying I'm going 2 to the left, in order to map, I'm going to have to go x minus 2. I'm taking that coordinate and I'm subtracting 2 from it. It's right? It's the same thing. So if I did mapping, x, y becomes, I have to take my x coordinate, I have to subtract 2 to move 2 to the left. And then y. For B, it says replace y with y minus 8. So I take the y, I toss it behind my head, and I put in y minus 8, right? So I'm going to take this y, toss it, replace it with y minus 8 equals f of x. And then personally, I always switch it into y equals. So I'm going to go f of x plus 8. So what translation is that? Vertical translation, 8 up or up 8. And then my mapping is the same thing. So xy becomes x comma y plus 8, because that's how I move the coordinate up. Yeah.
Do you have to move the 8 over?
Nope. You don't have to, but by the time we do 8,000 different extra adds to this, you're probably going to move it. Because they aren't going to give you just something with just an 8 on it, right? They'll often give you a vertical stretch, horizontal stretch, a reflection, a vertical translation, horizontal translation. Example 3. The point 2, negative 3 lies on the graph of y equals f of x. State the coordinate of the image. Image means movement. They'll say image of the point under the following transformations. We are moving a point. What are we going to use? Mapping. We move a point, we use mapping. We move a graph, we're moving a whole bunch of points, we use mapping. Now you might be like, Lepp, today I don't have to. You're right. However, we're going to be adding a whole bunch to this, and then you're going to be in trouble. So we're going to keep practicing our mapping and doing it correctly, so that in 2 days, when we have way more things added, we just rock it. So I know I'm moving a coordinate, so I'm going to use mapping. I'm going to subtract my 8 over. So I'm going to do x, y becomes, so I need an arrow, x, and then y what? Minus 8, because I need to move down 8. X moves right or left, y moves up or down, right? So I'm going to do it to the y, minus 8. Then I show it. So I go 2, comma, negative 3 becomes 2, comma, negative 3 minus 8. So my new coordinates at 2 and negative 11. You do B. So when we go to do this one, we have x, y. I'm moving 7 to the what? To the right, which means I affect the x. So I'm going to add x plus 7. And then I'm moving 5 up. 5 up affects the y. Some people try and memorize transformations. It goes really badly, really quickly. Don't memorize. Understand why you're moving things. So if I'm moving 7 right, then I go to my x, because my x is my right-left movement, and I have to add 7 to it to get it to move right. Right? Correct. 2 comma negative 3. 2 plus 7 comma negative 3 plus 5. And then we get 9 and 2. So for example 4, I'm giving you an equation y equals f of x after each transformation. So you're going to have to give me, these are not embedded together. It's not like this one, then this one, then this one. This one just has 5 left. So give me a new equation. This one is just vertical translation 3 up. Give me a new equation. This one is m right and p down. Okay? So come up with the 3 equations using this as your original function. So if we're moving 5 left, we're going to have y equals f. If it affects the x, it's with the x variable. In mapping, it's with the x variable in equations. So we've moved 5 left, so we're going to have x plus 5. This one we need to move 3 up. So you can either give me x minus 3 equals f of x, or you could have given me y equals f of x plus 3. Both of them are the same. Horizontal translation, m right. So we're going to go y equals f, m right. So we're going to go x minus m, and then p down, so minus p, or y plus p equals f x minus m. Which one's better? The one that matches the multiple choice answer. That is better. Either of them are actually better. Okay? If it was a written response, they'd both be acceptable, unless they said in the format of y equals. Okay. Now we're moving we're moving a graph, which means we're moving a whole bunch of points, which means we're still going to use what? Mapping. I'm going to get you guys to do this one. So we're going to subtract the 2 over. So what is my mapping going to be? xy becomes x minus 3, because I'm moving 3 to the left. Y minus 2, because I'm moving 2 down. Now I'm going to show you, we're going to omit this one for now for time constraints. But I'm going to show you how I would do it. Now people will say, can't I just go 3 left and 2 down and draw a new dot? Absolutely. If it's this easy, I'd go 1, 2, 3, 2 down. 1, 2, 3, oops, 1, 2, 3, 2 down. This is the catch though. As you draw the dots, connect the dots. Don't be like, I'll do this one. No, I'm going to do this one. No, the graphs, people will draw all the dots and they connect them wrong. So do a dot, draw a dot, do a dot, draw a dot, connect a dot. Not sure why I'm sticking with black here. And then I'm going to go 3 left. 1, 2, 3, 2 down. Then I go 3 left. 1, 2, 3, 2 down. 3 to the left, 1, 2, 3, 2 down. So with a graph that easy, I do expect that you're probably just going to draw it, correct? But when they're more advanced, you're going to actually have to plug them into your mapping. So you have xy becomes x minus 3, y minus 2. You're going to take this coordinate, which is 1, 2, 3, 4, 5, 6, negative 7, and 2. And you're going to go negative 7 minus 3, 2 minus 2. So I'm going to get negative 10 and 0. And then I would draw it, which is what I drew anyways. And you'd have to do it for every single coordinate, correct? And then you would just draw the coordinates as you go along and connect them. We agree? When they're this easy, though, you actually make more mistakes doing that. Now, they often aren't that easy. They often have a whole bunch, so your easiest way to do it is mapping. And when we do rubrics for this, it'll be like if one point is wrong, like you'll go through and it'll be like, if one point is wrong, you're like, okay, 2.5 out of 3. Or, if one point is wrong, 1.5 out of 2. If 2 points are wrong, you might bump to a new, like to 2 out of 3, right? Or 3 points wrong. So the rubric tells us how many you can have wrong. And often people will mess one up. They'll just, I don't know, bad algebra. And then they'll be like, if the mapping was completely wrong, but it was done correct, does that fall in the rubric? So like say you went x plus 3, y minus 2. Your y minus 2 was right, but your x plus 3 was wrong. So they give us a rubric as to exactly where you fall. So here, I gave you mapping. We're not going to do this one, because what would you just do? Put in the numbers, get an answer, right? Bypass. Go to 7. Determine how the graph of the second function compares to the graph of the first. Now this is the key thing. For the first one, what do we have? X plus 4, x plus 4. Is this with the x? If it was with the x, it would be bracketed x plus 4 to the 4, right? So it's not with the x. So what type of transformation is it? It's a vertical translation. 3 up. B, people will do wrong. Because they'll tell me, well, I don't know what the 6 does in front. That's something if you remember from last year's vertical stretch, but then they're like, -3, go 3 down, and then I go 1 right. When you state transformations, it's what changed, what the graph transformed to change, correct? What's the only thing that changed? Just the x minus 1, right? The 6 was there already. The 3 was there already. So all that happened here is a horizontal translation 1 right. That's it. If you state all the rest, that didn't happen. That was there before, right? Transformations are what happens between. So if you're someone who's like, yeah, I would so write all of them, leave yourself a star note. Maybe highlight it. Be like, don't. Only write what's changed. So this would be a horizontal translation. One right. C is an absolute value function, which makes a V. Do I even care? Not really. Don't overthink the questions. Just go, is it with the x? Yeah? So it's a horizontal translation. 6 what? 6 right. And the 2 is different. So it's a vertical translation. 2 up. D is a rational function with a radical denominator. It's kind of crazy. Do you even care? Nope. We care. What's with the x? What's not with the x? The problem with this unit is people overthink it. They're like, I don't know what that is. Well, first off, you could type it in and look at it if you really want to. Super pretty. Super pretty graph. So here we have a root x. Here we have a root x plus 1. So that 1 is with the x. It's being added to it. So it is a horizontal translation. One left. Then I have a 3 sitting at the back. What's that always? Vertical translation. 3 up. We're going to flip over. So this is different than those f of x ones. The f of x ones, I just told you to give me the transformations. You threw it in with x, so you threw it at the back, right? Now I'm giving you actual different functions. The top one is a quadratic, which you dealt with last year. The second one is an exponential, which you're going to deal with this year. And the third is a radical, which you dealt with the function operations on it, but this year you're going to deal with functions of radicals. Do you care?
No.
No. You will later when you actually take units on that, but right now you don't care. If it's a horizontal, it goes with the x. If it's a vertical, it goes at the back, or it goes with the y on the other side in the opposite sign, right? So you try A, B, and C. So A, we have y equals x squared, horizontal translation 3 to the right. So what are we going to get? Y equals? X minus 3 in brackets squared. Then we have a vertical translation 2 up. So we could go y minus 2 equals 10 to the x, or we can move it over and we can go y equals 10 to the x minus 2. If it was a horizontal translation, it would be added to the x up in the exponent.
Shouldn't it be plus?
That's what it says. I have no idea what you're talking about. Miraculously, poof, magic, see? Canada's Got Talent. Ain't got nothing on me. I just made that happen. All right. And then C, y equals square root x. After a horizontal translation, 4 units left. So we're going to get square root x plus 4. And then 3 down, minus 3. Or y plus 3 equals square root x minus 4. Because we can move the 3 over and make it minus. All right. We're just going to look at example 9a. So here, the hardest part of this question is figuring out which one is the original and which one isn't. So read thoroughly. Don't call me over. So it says, the function represented by the thick line is a transformation of the function represented by the thin line. Which one's the original? The thin. The thick is the transformation of the thin. Write an equation. These are the same. Enjoy today, because all there can be is horizontal and vertical translations, because I haven't taught you anything else. So let's figure out what we did. So we're going from the thin to the thick. So we have to go 1, 2, 3, 4 down, and then 1, 2 right. Because we go from the original to the transformed, correct? Now our original is labeled. It's f of x. So that's y equals f of x. So we're going to get y equals f x minus 2 to go 2 right. 4 down is minus 4. Or we should have started off with the other one. Y plus 4 equals f of x minus 2. I have way more examples because these are my 30-1 notes, and they need more examples sometimes. Okay, then flip over. Okay, this is where our brain matter needs to be used. Also bringing back a little grade 10 again. So we have y equals square root x is a radical function. What vertical translation, so what does that affect? My y. I'm affecting my y. I don't know how, but I am. Would be applied to y equals square root x so that the translation image passes through this. So this is the new point. If I had the old point, the original point, I could just figure out how much I moved to get 7 and boom, I'd be done. Correct? So how could I get the original point? Anyone have any ideas? In your calculator, but how? How? What would the original point have been? Yeah?
So you're going to add a variable where the translation for a vertical one would be. So like, for example, y equals the square root of x plus m. And then you would plug in those points for the y and x. And then I think you solve the variable that you'll see for the translation.
So you're saying what's not changing?
Horizontal is not changing.
The horizontal is not changing. We agree? Yes. So if the horizontal is not changing, can we not find the point on the original where the horizontal was what? 16, because that baby ain't changing, right? So my original point is at 16 and something. And it's going to become 16 and 7. They can only ask this question if they're only changing x's or only changing y's, correct? They have to leave one of them stay the same or else we're in trouble. So how do I get the original y? You can plug in your calculator, or you were taught to do t-tables where you could find any y if you were given an x, you find any x if you were given a y, but just plugging it into the equation, correct? So I know x is 16. So I could go y equals square root of 16, and what's my y equal? 4. That's what your calculator is doing every single time. It's just doing the math for you. So your original point was 16 and 4, because you just plugged it in. Y equals, for the x, 16, you got your y. So what did we do? Vertical translation 3, what? Up, because we went from 4 to 7. The next one you're going to try on your own, it's a horizontal translation only happened though. So now your what doesn't change? Your y. Try it out. That doesn't mean it's wrong. Okay, so for this one we have a horizontal translation. So this moved, this stayed. So on our original, our y is 8. So 8 equals square root of x. How do I get rid of the square root? I square it. So x was 64. So our original point was 64 and 8. It becomes 17 and 8. So how many did I move? To the left, because I was at 64. I'm now at 17. I moved 47 to the left. So horizontal, translation, 47 left. I'm just gonna look, this is my normal homework, I just wanna do those, the ones that aren't blue. People will be like, but I can't read through the blue and you highlighted them. I'm like, I didn't highlight, I crossed them out. I get that sometimes. I'm like, I ain't highlighting, people.